Hey everybody, this is my first video recorded math lesson of the 2020 school year for 4th grade, so I hope everyone's able to follow along with me. The nice part is you'll be able to pause the video at any point if you need to take more time to do some work, or if you need to hear what I said again, you can always run the video back and hopefully it'll make sense the way I'm explaining it to you. I'm using my camera from my room that I usually project up on the front screen, so I can do that, but I can also, flip that around there. Pretty cool. I can show you the lesson that we're going to be working on, which is lesson 1 in the materials that I sent home. On page 53 is where it starts out on, so I ripped those lessons out of your book and stapled them together. So it's lesson 1 on page 53. Explore multiplicative comparisons. Okay, and we see the I can statement says today I can use visual models and equations to represent and interpret a multiplicative comparison. Okay, multiplicative, you see the word multiply right there. Okay, multiply. So multiplicative comparisons are how we're going to be showing comparisons that multiply rather than just more than or less than like we have been with addition and subtraction. So now our comparisons are going to be multiplicative. Okay. It also says here we're going to be using visual models. So we're going to be using the space in our book to draw pictures and make visual representations and also write equations. Okay, so we're going to be practicing those 3 main things today in our math lesson. Okay, let's go ahead and get started. I will read the first question to you. And I just want you to take notice of the image that you see over here, and I want you to think about what that looks like to you. And to me, it reminds me of a bullseye target that you might see in archery, or maybe perhaps a dartboard if you were throwing darts at a dartboard. But usually when we play a game like this, the farther away you are from the center point, you get fewer points, and as you move in closer to the bullseye, you get more points. So let's take a look at the question underneath Spark Your Learning. Jasleen throws 2 balls at the target. She gets 4 points for landing on red. She gets 3 times as many points for landing on green. Use a visual model to show how many points Jasleen gets for landing on red, then show how many points she gets for landing on green. Okay, so let's just think about that for a moment. And maybe now would be a good time for you to pause the video and read that question again to yourself. And now that you've paused the video, I'm going to read through it one more time. I like to do 3 reads when it comes to these questions for clarity. Jasleen throws 2 balls at the target. She gets 4 points for landing on red. She gets 3 times as many points for landing on green. Use a visual model to show how many points Jasleen gets for landing on red, then show how many points she gets for landing on green. Okay? So it says, in my question here, it says that she gets 4 points for landing on red. So we could represent that in any number of ways. Okay? I'm going to use my space down here below, and I'm going to say red. Oh, I don't know. I'll just use these 4 little circles. Okay? Those 4 little circles are showing me that red is good for 4 points. Okay? Now, green, it says in my question, she gets 3 times as many points for landing on the green. 3 times as many is a different statement than as if it just said 3 more points, right? We're not just saying that she's getting 3 more points, we're saying that she's getting 3 times as many points. So our green I'm actually going to use the same color here, even though it's green and red. So green is, if it was the same amount, right? That's what it would look like if it was the same amount. Or in otherwise, if it was 1 times as many as the red, it would look like that. Okay? So now think about it. If it was 2 times as many, what would that look like? Well, we would need another bracket with the same number of points as there are in the first time. So that would be another 1, 2, 3, 4. that would be 2 times as many as the red. Okay? And you're probably saying to yourself, oh, 2 times as many as red. Well, green would have 8, red would have 4. Okay? The question again says that it's going to be 3 times as many points as the red. The green has is worth 3 times the points as red. So again, I would do 1, 2, 3, 4, and there I have a visual representation of 3 times as many points for the green as opposed to the red. Okay, and if you look back up here, you do see that this ball landed on the green area here, so it's closer to the bullseye. So it would make sense that you would get more points for where this ball landed on the green than you would on the red. Okay, so now we can look at our visual representation, and then we can make a determination. Okay, so then we could say Jasleen gets 12 points for landing on green. Okay? So now you're probably thinking to yourself, oh, I get it. 4 points 3 times is the same as 4 times 3, which equals 12. So if you remember from the I can statement, we said we were also going to use equations. Okay? So we have our visual representation here. This is our picture. This is our equation to represent the multiplicative comparison of these numbers. Okay? All right. If you're with me, give me a thumbs up that I cannot see, because it's a video. All right. Next page, on page 54. The nice part about the videos, guys, is that you can pause as often as you need to. Okay, take the time, solve, go back, listen to me again. I'm sure some of you probably wanted to pause me in real life before, too. Maybe even mute me. All right. So the next page, page 54, build understanding. Okay. Tomas unlocks 2 levels in a video game. Sasha unlocks 5 times as many levels as Tomas. How many levels does Sasha unlock? Use a visual model to represent the problem. Okay? So let's think about the problem that we just did. Okay? We got the information and we knew how much the original point value was, 4 points. And we knew that in order to find the next point value, we had to multiply or show a model of the original points 4 times 3. Okay? So in this problem, Tomas unlocks 2 levels in a video game. Sasha unlocks 5 times as many levels as Tomas. How many levels does Sasha unlock? Use a visual model to represent the problem. Okay? So for this problem, we have Tomas and we have Sasha. Okay. How many levels did Tomas unlock in his game? Well, he unlocked 2, right? And Sasha unlocked 5 times as many as him. Okay? So I'm going to start out again. This is what 1 time would look like. Okay? This was her. This would be 1 time. So we need to represent what it would look like if it was 5 times as many levels as Tomas. So if I was going to do a second time, I would have 2 more. Three times, 2 more. Okay, 4 times, 5 times. Apologize, my pen's a little bit wonky, so it's not very neat. But we can see there now, we took Tomas's amount, which was the 2 levels that he unlocked, and then Sasha took that to 5 times as many. So we've got her representation down there now as well. Okay, so how does your visual model show the number of levels Tomas unlocks? Well, Tomas, or you could say I drew 2 squares to show 2 levels. Okay, that's sort of like our key right now. We understand that we did a question last week about pictographs. Okay, so basically we're saying that each square is a level. So if Tomas has 2 squares, he's got 2 levels. Okay, how does your visual model show that Sasha unlocks 5 times as many levels as Tomas? Well, think about what we did here. Okay, I drew groups of 2. Five times. I drew groups of 2 squares 5 times. And by doing that, I'm showing 5 times as many as 2. Okay, sorry, I know that my pen sort of bled through on the page there. Hope everyone can read what I've got there. Okay. Now C says complete the comparison and multiplication equation to describe and model the problem. Okay. So we can now say 5 times as many as 2 is, so this is what we wrote down as our statement here. This is what our visual representation shows. So now we want to just put it into an equation. 5 times as many as 2 is 10. Therefore, 5 times 2 is 10. Okay? Whenever you see that word is in math, it always means equals. So 5 times 2 is 10 equals 10. Right? Sasha unlocks, therefore, 10 levels. Simple enough, right? Okay. Any questions? If so, jot them down, make a note of it, and when we have our Google Meet, you can ask for clarification. Okay? All right. On the next page now, Landon, hey, just like our Landon, except it's not spelled the same. Landon wins 4 tickets for playing a car game. He wins 6 times as many tickets for the space game. How many tickets does Landon win for the space game? Okay, now they're asking us to draw a bar model to represent the problem. Okay, a bar model is similar to what we were just doing. However, we're just going to use a bar rather than a pictograph. Okay, so a bar model to represent the problem. I'm going to read the problem one more time. Landon wins 4 tickets for playing a car game. He wins 6 times as many tickets for the space game. How many tickets does Landon win for the space game? Okay, so we have 2 games. We have the car game and we have the space game. Pens are dying out on me here. Okay, for winning the car game, Landon won 4 tickets. Okay, so I just have one little bar there with a 4 inside of it. The space game, however, he won 6 times as many. So if it was 1 time as many, he would have won 4 tickets, right? But it's not just 1 time as many. It's not even 2 times as many. It's 6 times as many. So I have a long bar that I'm going to break into 6 equal parts. Each part being worth 4. Okay? This is a multiplicative comparison that we're doing right here. We're showing that by repeating the number 4 6 times, I'm representing what that statement looks like compared to the original number of tickets won for the car game. Okay? Now this big long bar here, we can see, is 6 4s. In other words, it's 6 times 4, or 4 times 6, however you want to think of it. Okay? But either way, it's a total of 24, right? So what are we modeling? What equation can we use to model the problem? We could say it's 6 times as many as the number of tickets earned, so 6 times 4, which equals 24. Okay? Now the next part says, interpret your equation as a comparison. Okay? So now we kind of need to do the inverse, or the opposite. Okay? You know that the opposite of addition is subtraction. The opposite of multiplication is division. So we want to sort of think about this in the opposite sense of this comparison. So if you take the total number of tickets earned from the space game, we would say 24 is how many times as many as the original car game? Well, 24 was 6 times as many as 4, because that was the original car game. Alright? And then, as a last kind of piece to wrap up the problem, it says Landon wins 24 tickets for the space game. Alright? So, you could ask yourself, how does your visual representation here mean the same thing as here? Okay? Hopefully you're able to see that you've got 6 4s here. 1, 2, 3, 4, 5, 6, which equal 24 if we were to skip count by 4s. 4, 8, 12, 16, 20, 24. Okay? Alright. Alright. Check your understanding. A superhero video game uses 6 coins. An airplane game uses twice as many coins as the superhero game. How many coins does this airplane game use? Complete the bar model, comparison, and equation to solve. I want you to pause your video for a moment, and I want you to read that question again to yourself, and then I want you to try to fill in the visual representation here along with the equation, and see if you can do that on your own. And if you paused your video, now we're back. So now I'm going to record my information into my graphic organizer here, and I'm going to say that the original problem told me that a superhero video game uses 6 coins. So on my first line, I'm going to write superhero and 6. Then the next part of my equation says, or the next part of my word problem says, an airplane game uses twice as many coins. So then airplane would have not 1 times as many, but 2 times as many, for a total of 12. Alright? Now, these blanks down here can be confusing, so kind of think of what numbers fit in there to make it a true statement. Something times as many as blank is blank. Okay? Blank times as many as blank is blank. Okay? So we're going to use the information from the problem where it says that twice as many coins, so that's my clue to say 2 times as many as 6 coins is 12. Okay? Remember that word is means equal. 2 times as many is my evidence that I'm basically just saying 2 times 6 equals 12. So therefore the airplane game uses 12 coins. Okay? Alright. Now hopefully with those 3 examples that we've done together, you would be able to take this next challenge on your own and be able to solve some of the problems by yourself. Okay? So at this time, I want you to practice the on your own by pausing the video, reading the questions to yourself, and filling in the blanks as they come to you. Alright? After you've done that, you can restart the video and see how you did. If you want to hear me read the questions to you, okay, I can read the question and I won't do any solving. You just pause the video after I read it to you. Okay? So now would be the time that you would pause the video to do your own independent practice right now. Number 2 says, Frank and Sherry play basketball. Sherry makes 2 baskets. Frank makes 4 times as many baskets as Sherry. Complete the bar model and write an equation to find out how many baskets Frank makes. Okay? So the information from the problem tells me that Sherry makes 2 baskets, Frank makes 4 times as many as her. So I'm going to use my bar model up here to put in the names Sherry, who made 2 baskets, and Frank, who made 4 times as many. So since Frank made 4 times as many, this is going to be 1 times as many, 2 times as many, 3 times as many, and there's my 4 times as many. So if I have 4 times as many as 2, I would have 2, 4, 6, 8. So my equation would say 4 times as many as 2 equals 8. Okay? Sorry, I got a little blurry there. Okay? Now, next, model with mathematics. Write a multiplication equation to model the comparison. Okay? Think about the way that I just read this one to you. Sherry makes 2 baskets. Frank makes 4 times as many baskets. Complete the bar model. So we said 4 times as many as 2 is 8. So 21 is 3 times as many as 7. So that would say 21, remember the word is means equal, 21 is 3 times as many as 7. Okay? Now in the next one, it says 8 times as many as 6 is 48. Notice how I put the 21 here first? I did that because the 21 came first in my expression here. 21 is 3 times as many. So I'm writing down what I see. Now I see 8 times as many as 6. So I'm going to write 8 times as many as 6. I see the word is, which means equal, 48. Okay? The next set of questions says interpret the multiplication equation as a comparison. 45 equals 9 times 5. So what could we write down there that means the same as that as a comparison? Well, think about which one of these does this problem look like. Does it look more like number 3 or more like number 8? Okay? It looks more like number 3 because 45 equals 9 times 5 is written the same way as 21 equals 3 times 7. So to write my statement, I would say 45, I see the equal sign, which means is 9 times as many as 5. Okay? And that's a true statement because I know that 5 times 9 is 45. Okay? For number 6, this equation looks more like the one I wrote for number 4. So I'm going to model my statement the same way that number 4 was written, which would look like this. 4 times as many as 7 is 28. Don't forget my periods. Okay? All right, one last question on that page. Construct arguments. Helen and Jamal write different equations to model the comparison. 40 is 5 times as many as 8. Who is correct? Well, let's look at their work. Helen, 40 equals 8 times 5. Is that true? Does 40 equal 8 times 5? Well, Jamal wrote 40 equals 5 times 8. Is that true? All right. Hopefully from your work in reflex math and your knowledge of multiplication facts, you know that they are both correct, right? They are both correct. Okay, why is that true? How do we know that they're both correct? Well, we know that whether it's 8 times 5 or 5 times 8, the order of the factors does not change the product. And when I say the product, what am I talking about? Talking about my answer to my multiplication statement. Okay? All right, guys. Now, we've completed lesson 1. In your materials today, you have a extra practice / homework assignment for lesson 3.1 where it says more practice / homework. It says P19 at the bottom. Okay, let me just flip you around here. Whoop. So I'm talking to you again. There we go. So it says P19. It's the gray paper that came out of your darker blue math book. I ripped that page out for you. So you've got it, and that is now your homework, which basically it's all homework right now. So that is your extra practice. Keep track of that. Don't lose it. Keep it in that folder that I sent home for you, and I'm going to use that as evidence to check your work. Okay? Good luck, guys. Yes, you do need to do the front and the back, Trevor. Okay? Front and the back. And I will be checking that when I can collect it from you the next time. I don't know when that's going to be, so just hang on to it. Okay? Hope you guys have a great day, and I will see you again real soon.